This is a big 3D printer. That much is obvious. But bigger isn't always better. The bigger they are, the harder they fall. And fall they will. It's how they pick themselves back up again that really matters. In this video, we'll be putting this large printer through a long list of tests to see if it can rise to the occasion. So stick around to see where it shines and where it struggles. It's the SV08 Max from Sovol, the successor to the wildly popular SV08, itself a commercialized interpretation of the Voron 2.4. The Max isn't just bigger, it's been improved in a myriad of other ways, which is good, because for as popular as the original SV08 was, it had its fair share of issues. The bed was thin and mounted to a plastic base, which made it prone to warping. The Max's bed has been completely redesigned. It uses an 8mm thick slab of aluminum with a PCB heating element rated for 1300 watts, with a thick piece of foam insulation underneath. This is mounted to the printer with a metal base, not plastic. The net result is a much more thermally stable surface that doesn't turn into a taco when heated. The bed heats fairly quickly, taking around 10 minutes to reach 100 degrees, with a peak power draw of around 1350 watts. In 110 volt countries, this puts the current draw at near what a 15 amp circuit can provide, so you might trip a breaker during the initial heat up if you have anything else on the same circuit, so be careful. After heating, the power consumption during normal printing drops to between 150 and 250 watts. First layer issues on the original SV08 also stemmed from the methods employed for bed mesh generation and determination of Z offset. It used an inductive probe to measure bed topography, and a pressure sensor at the rear of the bed to determine the nozzle height relative to the build surface. This didn't account for any variation in the build surface height on account of thermal expansion during heating, resulting in a first layer that was rarely consistent. The Max replaces the inductive probe with an eddy current scanning probe. Not only does this yield a much higher resolution mesh in a much shorter amount of time, it also allows you to determine the Z offset using direct contact probing with the nozzle. There were a few instances in my testing when I had to baby step the first layer slightly, but overall it was consistent. Here's a visualization of the bed mesh, a deviation of around 0.5 millimeter over the span of a 500mm bed, which is quite good. It's not perfectly flat, but it's certainly more pancake than taco. The ripples you see, I believe, are a result of mechanical vibrations of the printhead during the scanning process. Speaking of which, here's a look at the frequency response of the toolhead. A solitary resonant frequency on Y, and for the most part on X, with maximum recommended accelerations of 5300 and 7300 respectively. These values are lower than those from the smaller SV08, as are the resonant frequencies. The Max, with its larger build volume, has a heavier gantry and longer belts, both of which tend to decrease the natural frequency of vibration. Printing motions tend to excite these lower frequencies, resulting in resonance. Input shaping helps compensate, but it can only do so much. I observed a fair amount of ringing in my test prints, particularly the glossy ones. Perhaps owing to the fact that the acceleration limit in firmware is 40,000, 7.5 times higher than what the resonance response dictates is optimal. This is what happens when you let the marketing department, rather than the engineers, dictate your performance specs. The secondary effect is that the sharp details in our prints are lost as a result of the smoothing that comes from the aggressive input shaping required to mitigate ringing at these high accelerations. The prints might look okay, but you shouldn't expect them to be particularly dimensionally accurate. There's probably a reason why the maximum size of a Voron 2.4 is 350. Larger sizes are possible with custom builds, but not recommended or officially supported. But I'm getting ahead of myself. Hi, if you're new here, I'm Taylor, and this is Y2K3D. I like to deep dive into the technical details of 3D printers, and I won't shy away from telling you the cold hard truth of my findings, even if it hurts the feelings of the companies that send me free products to review, as Sovol did in this case. If you enjoy this type of content, please do yourself and I a favor and subscribe to this channel by hitting that button down below. Sovol went with standard 6mm width belts on this printer. I would have liked to see them use a thicker and stiffer 9mm belt instead, which could have helped with resonance. The belts might be a little undersized, but on the other hand, Sovol has done what they can to reinforce the frame of this printer. They've switched from a 40-20 profile, as on the original SV08, to a 40-40 profile for the Z-axis uprights, and added 8 steel brackets to act as reinforcing ribs in each corner of the frame. The Core XY motion system maintains the iconic flying gantry design, which is a staple of the Voron 2.4. Each corner is driven by a dedicated motor and is independently height adjustable, enabling automatic tramming of the gantry relative to the bed. But there's a drawback. When the motors aren't energized, the gantry is susceptible to sagging under its own weight and the force of gravity. This can wreak havoc on the ability to recover a print after a power loss. This is the case on a traditional Voron 2.4. On the SV08, however, the motors have dampers that add rotational friction to the shafts and prevent them from moving under the weight of the gantry. In fact, it's difficult to move them at all, even using excessive force. The original SV08 also had motor dampers, but they've been beefed up on the Max. Another thing that's been beefed up are the motors themselves. The Max uses high current rated 48mm NEMA 17s for the AB motors, with heatsinks added for thermal regulation. These are paired with TMC 5160 stepper drivers, supplying 3 amps of RMS current. Contrast these with the regular NEMA 17s and less capable TMC 2209s on the original SV08. The Max, despite having to move more mass, is able to match the accelerations on account of the increased torque output from those motors and stepper drivers. I don't normally talk about the noise level of printers because it's just not that interesting to me personally. I'm pretty used to the sound of printers running. But I must say that this one is particularly loud. The stepper drivers whine in a way that is reminiscent of the original Ender 3, particularly at slow speeds. And the auxiliary feed mechanism, more on that later, makes a distinct motor noise every time it actuates, which isn't exactly quiet. And the fans are pretty loud too. Continuing our hardware tour, let's have a look at the printhead. From the outside, it looks visually similar, but the internals have been refined. We still have the same direct drive extruder with a planetary gearbox and hardened drive gears. I particularly appreciate the rotation indicator on the extruder stepper motor, which makes it easy to detect movement speed and direction at a glance. The hot end has been redesigned with a considerably larger melt zone, capable of reaching a maximum temperature of 350 degrees, a 50-degree increase over the original SV08, and a hardened nozzle by default. Sovol claims a max flow rate of 50 mm³ per second. In my testing, it capped out at around 27 with high-speed PLA. The Max inherits the cooling setup of its predecessor, which includes a 50/20 radial blower in the toolhead cover and a smaller 3010 fan at the rear. This provides a tremendous amount of airflow for part cooling, which is both a blessing and a curse, as you'll see later. But perhaps the best improvement of all is the switch from USB communication for the toolhead to CAN bus. USB is more susceptible to electromagnetic interference and is generally less capable than CAN. This change will make it much easier to upgrade this printer, if so desired, with any of the common CAN toolboards on the market, from the likes of Big Tree Tech or similar. Sovol has also considerably improved the cable management, adding a cable chain to the Y-axis and various cable retainment features to hold it in place. A big step up from the floppy umbilical cord of the original SV08. Another considerable quality of life improvement comes in the form of the integrated touchscreen. Previously, the SV08 was supplied with a standard LCD screen with the option to upgrade to a touch HDMI screen. The touchscreen now comes standard. The interface is okay for basic interactions, but pretty significantly lacking in functionality as compared to Klipper screen. I'm sure it will only be a matter of time before the community implements that on this printer. In the meantime, you can access macros and other control functions through the fluid front-end web interface. It's here that you'll also be able to view the camera feed. The gantry-mounted camera provides a good vantage point for monitoring the progress of your print. Worth noting here is that Sovol isn't using the mainline version of Klipper. It's their own fork, as it was on the original SV08. But the Max's firmware was forked from a later version of Klipper that includes scanning probe support, one of the main features that was lacking on the original SV08, motivating users to migrate the machine to mainline. Networking options on the Max are plentiful. We have Ethernet, 2.4 GHz Wi-Fi, and 5 GHz Wi-Fi, an uncommon option on 3D printers. What's strange though is that this printer isn't compatible with the latest WPA3 authentication protocols. In order to get it connected to my network, I had to go into my router configuration settings and switch to the less secure WPA2, which is a little concerning. After making that change, I was able to get it connected, but I experienced frequent dropouts so I opted to use Ethernet instead. I tried disabling Wi-Fi altogether, but it kept automatically re-enabling. Overall, a less than satisfactory experience getting this printer connected to the network. Don't worry, we're going to do some hardcore print tests soon. But first, let's rewind and take a look at the assembly process. One of the biggest value propositions of these printers is that they provide a Voron-esque experience and a tidy package that requires minimal assembly. Vorons are highly sought after because of their performance, open source design, and inherent modability. But not everyone has the time or skill to build one from scratch, which can take days or weeks. The entire assembly process for the SV08 Max took about an hour. It's a series of basic steps, all of which are extremely well documented, with labels on every part. We build the frame first, attaching the 4 Z-axis uprights, then adding the top piece. From there, we bolt on a few accessories, like the screen, spool holder, and auxiliary feed mechanism. Then we go around and connect the various plugs, all of which are labeled nicely. The step-by-step process makes it easy, kind of like the step-by-step learning process on Brilliant, an interactive online learning tool and the sponsor for today's video. Brilliant helps you get smarter every day, with thousands of interactive lessons in math, science, programming, data analysis, and AI. You don't just learn by reading, you learn by doing. The experience is completely gamified, with user interaction prompts each step of the way. Every lesson is filled with hands-on problem solving that lets you play with concepts, a method proven to be 6 times more effective than watching lecture videos. Say you want to learn about AI. Brilliant will start with the fundamentals and progress along to advanced topics, testing your knowledge in the process in a fun and engaging way. To try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/ygk3d or scan the QR code on screen. You can also click the link in the description. You'll also get 20% off an annual premium subscription by using my link. Thanks to Brilliant for sponsoring this video. All right, I think it's about time we got to printing. Naturally, I started with some pre-sliced files in local storage. This Benchy print completed in just 10 minutes. It was pretty darn impressive to see such a large machine move so fast. The sharp details are definitely lost, but overall, it's a good result. Next, I printed this combination bed leveling and layer stacking test print. I was equally impressed to see that the first layer went down without issue. Ever so slightly too close in a few places, but otherwise perfect. The tall structure printed pretty well too. But upon closer inspection, there were some interesting artifacts. On the front face, there was a series of vertical fine artifacts, matching the pitch of the belt. I'm not going to go into too much detail here on this, but in my previous review on the Prusa Core 1, I roasted them pretty hard over how bad the VFAs were on that printer. So it's only fair I pointed out here too. One of the most common comments I received on that video was that the VFAs were a result of the toothed side of the belt being against a smooth idler pulley. Well, the SV08 uses toothed idlers and still has pretty noticeable VFAs. Not as bad maybe, but still there. So I'm not sure how to explain that. There's also evidence of ringing at the corners, a result of the resonance behavior discussed previously. And there's a different pattern on the back that seems to be periodic, but with much wider spacing. No clue on this one. I next tried printing the classic torture toaster. Things were looking good when I left for the day, but I came back in the morning to a breakfast of spaghetti instead of toast. It seems that the speeds were just too high to successfully print these small features without issue. But overall, the quality wasn't bad. The walls looked clean, with only slight evidence of under extrusion that could be mitigated with tuning of pressure advance. The top surfaces were impeccable, and overhangs were equally impressive, printing successfully all the way up to 80 degrees. However, dimensional accuracy was lacking. I managed to free the 0.5mm tolerance test, but in the process of trying to free the 0.4 test, I broke it in the process, and the rest were permanently fused. Your prints might look okay at these speeds and with these accelerations, thanks in large part to the use of input shaping, but you shouldn't expect them to be particularly dimensionally accurate. I started the toaster print again and used it as an opportunity to test the various failure detection features of this printer. With a printer this large, the stakes are much higher. A failed print could mean days of lost time and kilograms of lost filament. So features like runout detection and power loss recovery are crucial. The SV08 has 5 main failure modes it can detect: filament runout, hot end clog, spool tangle, extruder jam, and power loss. Many of these are facilitated by the auxiliary feed mechanism. This is a secondary motor that provides extra pushing force to relieve some of the strain on the extruder. It also helps during the filament loading process. After you insert the filament, you press the button on the front to start loading it automatically. It pushes until it detects resistance, then stops. Unfortunately, in my experience, it would receive a false positive whenever the filament reached this coupling between the two segments of PTFE tube. This required that I disassemble it momentarily to help it along. The LED on the front of the feed mechanism shows the current status. Green means filament detected, blue means there are feeding issues, and red means there's a tangle or a clog. When the filament runs out, the LED goes dim, and a signal is sent to the firmware to pause the print, allowing the user to reload before continuing. In my testing, it worked as intended. In order to test the clog detection, I simulated the stoppage of filament motion by relieving the tension on the extruder idler. This took longer to detect, but the print did pause a short while later and recovered successfully, albeit with a slight imperfection where it resumed. The feed mechanism uses a spring-loaded buffer to trigger the dispensing of filament to the printhead. When the buffer collapses, the feed motor kicks on to move the filament along. In the case of a filament tangle on the spool, the resistance on the buffer would prevent the feed motor from dispensing more filament. This raises an error condition, causing the print to pause. In my testing, this worked as expected. Jam detection works similarly. It's a protection against the failure of the feed mechanism to properly actuate the buffer in order to dispense more filament. If the buffer collapses and gets stuck in that position, an error condition is raised. But the only problem this is solving is one introduced by the mechanism itself. So this shouldn't be considered a value-added feature. And sadly, I found out about its existence in an unfortunate way. I'll come back to that in a minute. The fifth and final failure detection mechanism is power loss recovery. This is pretty commonplace on most modern printers, but somehow many fail to deliver on their promises. Well, I pulled the plug mid-print on the SV08 Max to test it. After reinserting, the screen prompted me to ask if I wanted to continue calling after power loss. So I said sure. And I'm pleased to report that it did resume successfully. There's a noticeable line where the pause and resume happened, but it's much better than a complete loss. And the gantry didn't seem to sag by any appreciable amount with the motors de-energized. So that's a win. For completeness, I should also mention a bonus sixth failure mode detection mechanism, AI. The SV08 comes preloaded with Obico, formerly known as the Spaghetti Detective, which can be used to remotely monitor your prints and detect spaghetti failures using the built-in camera. Some will call it bloatware and opt to uninstall it, but it's there if you decide you'd like to use it, and you just might. With all of that testing under my belt, I felt confident in attempting my first large print. I loaded some rainbow gradient silk PLA, sliced a cool model of a melting popsicle, and sent it. Things were looking good when I left for the day. Unfortunately, when I came back in the morning, the printhead was parked and the print was incomplete. But it wasn't just paused. It had been automatically cancelled on the count of a bad command requesting the printhead move out of the allowable range. Remember the jam detection I mentioned earlier? Well, it turns out that the buffer on the auxiliary feed unit got stuck. The firmware detected it and called a pause command. But for some reason, the pause command instructed the printer to move to a Y coordinate of 632, causing the firmware to get mad and cancel the job. In order to troubleshoot, I copy and pasted the pause macro into ChatGPT and asked it to rewrite it, ensuring the commanded move would never go beyond the 500mm movement limit. It gave me back something that looked reasonable, so I copied it back and saved the file. A quick test and it seemed okay, so I sent the print again. This time it completed successfully. The results were okay, but not great. There's some layer separation that is most likely a tuning issue. Either needs more temperature or less speed. There's also significant evidence of vertical fine artifacts. Okay, enough with the PLA. Let's move on to something a little more difficult, PETG. This was the nemesis of the original SV08, with many users complaining that it was simply untenable, with excessive stringing and a propensity for hot end clogging due to the higher printing temperatures. So let's see if the Max can do any better. I first needed to slice my model. These are the parts needed to install the CoPrint multicolor upgrade on this printer, which I'll be covering in an upcoming video. So get subscribed if you want to see that. The Max is supplied with a machine profile for Orca Slicer, and one very basic print settings profile. The rest is up to you. There are no supplied filament profiles. You can use the pre-canned system presets, but they're nowhere near well-tuned for this printer. The PLA profile is passable, but the PETG profile is a nightmare. The first attempt at this print was a complete disaster. It seemed significantly under-extruded, so I thought it might be a flow rate issue. I tried tuning the extrusion multiplier, but that appeared to be a dead end, as the default value was the best. I then tried lowering the speeds, matching them to those used in the structural profile for the Prusa Core 1. This helped a little, but not much. The filament just wasn't laying down nicely. Perhaps it's cooling too quickly. Aha, that's it. Remember how I said this dual part cooling fan setup was both a blessing and a curse? Well, with the fan speed set to the default value, the cooling was much too much. I reduced it and that helped tremendously. I also kept with the lower printing speeds, which also had a positive impact. Here's a side-by-side comparison of the PETG printing results before and after tuning. I think a lot of us are used to printers these days coming pre-tuned with decent profiles, so it's definitely frustrating to have to do all this manual tuning and calibration, although some people will say that's part of the fun. I then reattempted my original print. The result was orders of magnitude better than where I started, but I'm still not that happy with it. The layer lines seem really prominent, and there's definite evidence of ringing. And that's about as far as I got with my testing. The Max, like the original SV08, has an optional enclosure kit, which would make it possible to print ABS or other warp-prone materials. The difference is that the Max enclosure will also feature a chamber heater capable of reaching 65 degrees, and an exhaust fan to filter particulates. There aren't very many options on the market for a large format heated chamber printer that's mostly pre-assembled, so this is certainly intriguing. But at this point, I'd be hesitant to recommend this printer for anything but PLA, unless you're prepared to do extensive tuning. Given my findings here, and the fact that Sovol supplied me with exclusively silk PLA for testing, it's become apparent to me that this printer is best suited for printing large aesthetic models, for which dimensional accuracy isn't of paramount importance. But all in all, the Sovol SV08 Max is a solid printer. It's a big step up from its predecessor, having been refined in a multitude of ways. It's reasonable in price, large in size, quick in speed, and reliable in its operation. But it's still a little rough around the edges in a few ways. And as much as the marketing department might say otherwise, there's no denying physics. A printer this large just can't print as fast as its smaller counterparts while maintaining the same quality. But with very few other options on the market for a printer with these specs, I definitely think this will have its place. Add in the fact that it's all completely open source and accessible for modding, and that's the icing on the cake. If these improvements trickle down to the more moderately sized SV08, that could be an instant bestseller. But I'd love to know what you think. Do you have a use case for a printer this big? And if so, what would you print? Let me know in the comments down below. And while you're down there, please give this video a like and consider subscribing for more great 3D printing content. Thanks for watching. My name's Taylor, this is YGK3D, and until next time, happy 3D printing.